Japanese professor Hiroshi Ishiguro developed a female humanoid robot named Minami to demonstrate the capabilities of modern robotics and artificial intelligence. Minami was introduced to the public at the Takashimaya shopping mall in Osaka, Japan. The goal of creating Minami was not only to amaze visitors, but also to enhance their shopping experience through interactive technologies. Minami is equipped with advanced speech and facial recognition systems, allowing her to interact with visitors naturally. The robot can recognize emotions and respond to them, adding a human-like element to interactions with visitors. Minami was developed as part of Professor Ishiguro's broader research into creating humanoid robots capable of social interaction. This research includes studying human behavior and reactions to interacting with robots, which helps improve the design and functionality of future inventions. Chinese robots never cease to amaze. Recently, at the EX Future Science and Technology Museum in Dalian, several new humanoid robots were introduced. These robots share wise thoughts with visitors, embodying the personas of famous figures such as artist Pablo Picasso, scientist Albert Einstein, philosopher Confucius, and other great individuals. To replicate the facial expressions of these well-known figures, specialists reviewed video materials featuring them. The synthetic use of humanoid robots, 3D holography, and interactive products annually attracts more than 200,000 visitors to the museum. The EX Future Museum specializes in the development of bionic humanoid robots and showcases the possibilities of advanced robotic technologies. Humanoid robots are also used in extracurricular education institutions. For example, in a robotics club, they assist teachers in conducting programming lessons and introduce children to the basics of robotic technologies. Actroid Sakura is one of the most advanced humanoid robots designed for interacting with people. Developed by the Japanese company Kokoro in collaboration with the Advanced Telecommunications Research Institute International, this android has an astonishingly realistic appearance and capabilities that make it stand out in the world of robotic machines. The primary goal of creating Actroid Sakura was to explore human-robot interaction and to use the robot in various service and demonstration applications. Sakura is capable of an impressive range of movements and facial expressions that mimic human emotions and behaviors. This is achieved through the use of over 40 pneumatic actuators that control her facial and body movements, as well as sophisticated software that manages her animations. Actroid Sakura's control system allows her to respond to her environment and interact with people in real time. The startup Houston Mechatronics has created the world's first underwater transformer robot called Aquanaut, capable of operating in unmanned mode at depths below 300 meters. Primarily, the robot is intended for deep-sea work on oil and gas platforms. Essentially, Aquanaut is both a submarine and a transformer with 2 manipulator arms. The robot can autonomously travel to its worksite and return, and can cover distances up to 200 kilometers. There are a stereo camera, a 3D sensor, and a sonar on its head. The arms are equipped with pressure sensors and grippers for capturing tools and operating valves that control the flow of hydrocarbons to the surface. The transformation process takes approximately 30 seconds. The device is powered by a battery similar to those installed in electric cars. In the future, the company plans to create a smaller version of the robot, capable of covering greater distances and operating at depths up to 3,000 meters, such as in the Gulf of Mexico. Introducing the world's first Centaur robot designed for rescuing people named Centauro. The robot is developed by specialists from the University of Bonn and the Italian Institute of Technology. The Robo Centaur stands 1.5 meters tall and weighs 93 kilograms. Its frame is made of lightweight metal alloys, and its body is covered with plastic parts printed on a 3D printer. Centauro uses 4 legs for movement, each equipped with a wheel at the end. The robot can both drive on these wheels and walk on its 4 legs to climb over obstacles. Additionally, the robot's torso has 2 arms, to which various types of manipulators can be attached depending on the situation. The battery charge lasts for 2.5 hours of continuous operation. According to the developers, Centauro can easily overcome obstacles thanks to its legs with 6 degrees of freedom, and it can lift heavy objects, making it ideal for search and rescue operations. The Japanese company Yaskawa Electric, a leader in the global market for industrial robots, has developed the next-generation robot SmartPal 7, which can be controlled using Microsoft's Kinect motion capture system. This innovative robot allows for remote operation, performing tasks such as lifting objects and cleaning. The SmartPal 7 is equipped with advanced components, including a stereo camera that can pan and tilt, an infrared sensor, and gyro sensors on its movable parts. These features enhance the robot's ability to autonomously navigate and safely interact with its environment and people. During a demonstration of the SmartPal 7, its remote control capabilities were showcased. An operator in Tokyo could control the robot located in Fukuoka, assisting, for instance, his mother with cleaning. The robot can pick up toys from the floor and place them in a box, demonstrating how simple operator movements can be translated into complex robot actions. The parallel axis Tripteron concept represents an innovative approach in the field of parallel mechanisms. The Tripteron mechanism consists of 3 kinematically identical legs and a motion platform. One of the key advantages of the Tripteron is its ability to minimize cumulative errors and increase the working area of the mechanism. The Tripteron mechanism can be manufactured using 3D printing technologies, which helps reduce the number of assembly errors and ensures a compact structure. This makes it suitable for various industrial and scientific applications, where high precision and reliability are required. The Menyuk excavator is a unique machine developed by the Swiss company Menyuk AG, designed to operate in the most challenging and hard-to-reach conditions. This excavator, classified as a walking excavator, can change its shape and position to adapt to the terrain. Equipped with 4 independent telescopic supports, the Menyuk can maintain stability on uneven surfaces and work on slopes up to 45 degrees. It features a powerful hydraulic system that ensures high performance. Depending on the model and configuration, it can lift loads weighing up to 3,000 kilograms. The machine is equipped with an engine ranging from 115 to 157 horsepower, providing sufficient power for various construction and earth-moving tasks. The excavator's hydraulic system allows for the use of various attachments, such as buckets, hydraulic hammers, drilling rigs, and more, making the Menyuk a versatile solution for a wide range of tasks. Write in the comments what you liked most after watching this video. If you enjoyed the video, don't forget to subscribe to our channel and leave a like. See you next time.